Okay guys, today we're going to review least common multiple. Okay, again, review. You've done this before. Same kind of twist, a little bit different from greatest common factor in that we need to learn a new method. Okay? The old way worked great for small numbers and when we only had two numbers. We need a little different method to handle the bigger numbers we're going to run into in junior high and to handle multiple numbers. Okay? First thing I want to do though is review what you know already. Let's start with an example here. 4 and 6. Okay? Just two example numbers. Alright? Now, don't even need to write this one down, but we want to find the multiples of each number. Okay? So, we start by going with 4 times 1, 4 times 2, 4 times 3, and so on. So, 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. Okay? This is also would be counting by 4. So if we keep going, 4 plus 4 is 8, plus 4 is 12, plus 4 is 16. 20, 24. I think that'll be enough. We start with 6, doing the multiples. 6 times 1 is 6. And 6 times 2 is 12. We keep going. So we'd have 18, 24, 30. That'll be enough. Okay. These are our multiples of 4. These are our multiples of 6. Okay? We could, on some numbers, have to go a long ways, but this is a pretty easy one. We want to find the least common multiple. So we need a number that's common to both lists, and we want to do the lowest one. As we can see right here, the least common is 12. It's in both lists. That's our lowest number. Okay? We use least common multiple for lots of things. Right now, I just want to focus on finding the least common multiple. Okay? You've done this before. It should be kind of ringing some bells. And for small numbers, this works great. The problem is when we get to bigger numbers, this can be really, really long. So we need to look at a new method. Let's look at some numbers that might be like that. Let's do 30 and 250. Now, I'm going to use the new method to do this. Okay? Because we might have to list out a lot of factors when we're dealing with big numbers. Especially when we're dealing with numbers that are a long ways apart. 30 to 250 is a big difference. Turns out we get to use our prime factors again. Okay? So the first step is to do the prime factorization of 30 and 250. Okay? Now, I'm going to go through this one instead of you guys writing this one, and just follow me here. I'm going to do, let's use a factor tree on this one. Just make it a little easier first time for some of you who like factor trees. Let's see, 30 breaks down to 3 and 10. Well, 30 is a prime factor. 10 will break down into 5 and 2. Bring down our 3. I'm going to relist these smallest to biggest. It'll make things a little easier earlier. So I have 2 times 3 times 5. That's my prime factorization of 30. Let's do 250. Well, an obvious one is 10 and 25. Multiply those together to get 250. 10 becomes 2 and 5. Those are both prime, so we're good there. 25 becomes 5 and 5. I'd have gotten the same answer whether I used the factor tree or factor boot. Now, notice here we have a bunch of 5s. When we're doing the least common multiple method, it will be easier to use exponents when we do this. Okay? So this would be 2, we only have one of them, times 5 to the third power. When we went through reviewing of prime factorization, we said that we could list these both ways. Okay? In this method, doing the exponents will be much easier. Okay? Instead of listing out 5 times 5 times 5, we can do 5 to the third power. All right? Now, let me switch colors here. Drop that one. Okay, here we go. Keep these lists separate. Now, here is where I don't want you to get messed up between least common multiple and greatest common factor. The numbers we pull down into our list are going to be different. Okay? So, in this method, here's what we're going to do. Start on your first list. Write down look at your first number. It's a 2. Notice that we also have a 2 in this list. It wouldn't matter if we did or didn't. If we have a number in both lists, we write the number down, 2, and then we look if there's any exponents on those numbers. Well, 2 does not have an exponent, and that 2 does not have an exponent. So we've got it wrote down. We can cross this off the list. Okay? Let's look at 3. We have a 3 here. We don't have a 3 on this list. We have an exponent of 3, but we don't have the number 3. We do not need to have the number in both lists on this method. Okay? So we need to write down a 3, cross it off. What's our next lowest number? It's a 5. Here is where this method gets tricky. Okay, here we have a 5, here we have a 5. We're only going to write 5 down once, and we're going to write down the highest exponent. This 5 does not have an exponent. This one does, a 3. So this will be 5 to the 3rd power. Okay? And I've crossed everything off my list. Okay? Different from greatest common factor. 2 different methods, but both of them work. Our least common multiple will be 2 times 3 times 5 to the 3rd power. If you remember order of operations, we should do the exponents first. 5 times 5 is 25. Okay, we'll do that over here. 25 times 5 again, because we had to the 3rd power. That leaves us with 125. So we have 2 times 3 times 125. Okay, we can simplify further. 2 times 3 is 6. 6 times 125. Let's do that over here. 125 times 6. That gives us a 0. Carry the 3. 6 times 2 is 12. Plus 3 is 5. And bring the 1, we get 750. Okay? That equals 750. 750 is our least common multiple of 30 and 250. Now right now you're thinking, I like the old way better. I don't need to learn this. Think of how many times you'd had to list multiples of 30 without making a single mistake on any of them just to get to 750. It'd have been about 25 times and not make a mistake on a single one of those 25 calculations. Okay? But we know how to get prime factors. We can do that pretty well. So we're just using that knowledge to make this into an easier problem. Okay? I want you to try this. Again, I know it's different.